Yeah, thanks for coming. Today you're here to talk about performance testing with Playwright. My name is John Hill, and a little bit about me. I'm a web UI test engineer here in Palo Alto, California, working at the NASA Ames Research Center. And I've been doing UI testing for about 10 years now. And I've been doing a little bit of performance along the way. But most recently, I took a job to work at the Ames facility out here to work on web UI performance uh, on the Viper mission. So for the past year, I've been working on Open MCT and the Viper mission. And the Viper mission is part of the Artemis program to send a lunar rover to the south pole of the moon and explore, resource, prospect, and drill for water. So water is most likely found as ice in the shadows of craters, which is unfortunate because our lunar rover is solar powered, so it's always a race against time. So it's a fascinating project to be a part of. And it combines kind of my experience with web UI testing, performance, and open source. I've worked for CloudBees and for Red Hat Ansible, so it was a great opportunity to stay in that space. And you can check out OpenMCT. I've included the link here in the slide notes, and I'll provide other links, of course. And it's what OpenMCT is it's an open mission control technology standard that's very pluggable and extensible, and works with various backends in the space industry and various space agencies, and allows mission control operators to get complete situational awareness about what's going on during the mission, and also allow scientists to kind of view data about the mission in real time and historically. So it's all running in a browser, and the UI designer is going to kill me because this version is over 5 years old, and I'm sure your designers at home would also kill you if you showed a 5-year-old version of the application. But he's on PTO, and I didn't get any clearance on providing any other version. So this is what we're going to look at today. But you can see kind of what we're working with here. So on the left are images streaming from the Apollo program, in this case. But the lunar rover drivers will see representations of the moon, and that's kind of juxtaposed with a display layout that they create for themselves here that can have any sources of telemetry, any sort of thing that they're curious about. Like the plan of what's going to happen next. All of that is made available. And again, all of this is browser-based, and you can see why there's, why performance would matter, right? This is mission-critical stuff, mission-critical software running inside of a browser. And so, I'm going to switch back over to the slides. So in this talk, we're going to talk about client-side performance testing. We're going to talk about what you can measure, and we're going to do this with Playwright. And all of the code to do all of this is found here. And it's not practical to follow along. Don't worry about it. We'll get play with it later. We're going to talk about the capabilities that Playwright provides for performance testing, some of the problems that are inherent with using Playwright, and some of the solutions. And we'll end with kind of a state of the union and what's coming next. Really exciting space, no pun intended. So in this talk, we're not going to talk about how to fix problems once you found them. And this is kind of, part one. I don't want to undersell this in any way. I haven't completed the journey. The mission launches until November 2023, which is going to be here before I know it. But not everything is completed, and I don't want to present it as that. So you can follow along by coming to this meetup group, or follow me on GitHub, for example, to kind of keep track of what I'm doing. And I'll be posting things on LinkedIn as I find them. And I hope to have maybe at the end of all of this kind of like a retrospective about what I learned along the way. But just super quickly, we'll talk about what client-side performance is, at least in the context as I've come to understand it. It's, it's a loose definition, but it's kind of the user experience while using a web application in a web browser. So kind of hand wavy, not a good definition, but it's really best and easiest to contextualize when something goes wrong. That's the thing about web performance is everything, it's one of those things you don't notice it until it's gone or until something goes wrong. And so the three easiest ways that I know to describe the problems associated with client-side web performance are long loadings, or things that are loading improperly or are visibly changing or loading slowly, slow relative to what we perceive to be okay by using web apps. We also have jank, or freezing or animation. That gets us away from the gold standards of 60 frames a second. So on the left you can see a Firefox spinning with some jank, and on the right you can see a Firefox spinning with perfect fidelity at a rock solid 60 frames a second. And then worst case is when your browser session totally crashes due to either an error, but oftentimes due to some sort of performance problem that only manifests over time, like a memory leak. So all three of those are kind of three things that kind of describe some of the problems associated with client-side performance. But there's another thing that is kind of maybe only applicable to web development teams, maybe not the users themselves. And this comes from a previous project that I worked on. This is another type of web performance problem, which is a junior developer broke the React hooks mechanism on this particular page on the left, which is kind of rendered out of screen. Sorry if it's a little bit difficult to screen, but the point is it's done loading, right? It's finished loading, but on the right you can see the network traffic for this given page. And what this person did was created the world's best load testing tool to take down our app because it couldn't resolve the state of the React hooks, and so it kept issuing more and more requests until eventually the backend gave out. So this is another type of performance problem that can be caused by the front end that may be even invisible to the front end. In our case, the functional test didn't find them. Certainly, because as far as the application was concerned, it was performing well. But there are other things that we need to be mindful of when we talk about client-side performance. So what do we measure? Well, when it comes to single-page applications or client-side measurements, is really what we are most concerned about are things after the first load, so after we have all of the assets on the initial page load. In my day-to-day, we don't care about necessarily how long it takes to get that initial load, because once you have that, all of the assets that you need, it's really what you do with them. And in some cases, it can, our users are using the same page for many hours. But the things to measure after the first load are network. It still matters after the first load in terms of latency, the number of requests that you're sending, what you're doing with those requests. That still matters. CPU and GPU, right? Sort of the jank and freezing that we're talking about, the frames per second, how efficient your code is, the JavaScript itself is, and how it's being rendered inside the browser. And lastly, memory. So memory is hugely important. In some cases, mission operators will be using the same page for 6 hours. I'm assuming there's a bathroom break, but I can't be sure. But what you have to worry about in that case is when he or she is moving around and using the app, that memory is released when no longer needed, object references are released, and that leaks don't form over time. So where do these measurements really come from? Well, they all thankfully come from Chrome itself. So Chrome does a very good job, the Chrome dev team I should say, at making all of these things that you would want to know about web performance available to the developer or the tester that's interested in this. And it does it through two ways. It uses, Chrome is driving some of these web standards. I think we're all aware of that. And a lot of the web APIs and the browser APIs are now standard. Sometimes they're experimental, but they're built in to the Chrome and basically any browser you'd want to use. But also, Chrome uses Chrome DevTools to kind of expose additional pieces of functionality. So the Chrome DevTools will expose the standards, but also kind of the DevTools API standards, which is really great. And so I'm going to break it down into those two first. So the web and browser APIs that we care about the most are available on the Mozilla Developer Network, but resource timing APIs, how long does it take an individual resource request to, how long does that take, and where does it spend its time? So the resource timing APIs give you a very insightful view of what was requested, what was received, and how long it took in between, and what it could do with that information. Something that's worth measuring in Playwright, and we'll show an example of that. The long tasks. So a long task API is a great way for proxying CPU, GPU, and animation measurement. And it effectively, what it does is it keeps track of where the main thread is locked for 50 milliseconds or more. And that's really what kind of gives you the appearance of jank. That lets you, it will break the illusion that things are animating completely. And it becomes a very good proxy of kind of keeping track of general CPU, GPU, and animation-based problems in your application. If something doesn't finish within 50 milliseconds, it's logged to the long task API, and then you can do something with that information. And the last one we're going to talk about, again, there's many more, but the last one we're going to talk about today is the user timing API, specifically the performance mark and associated performance.measure, again, built into all browsers. And the most famous example that I'm aware of for this API is when Twitter, 10 years ago, wanted to measure how long it took their user base to send their first tweet. Let me turn off Slack over here really quick. So what they needed to do was they needed a way to kind of keep track of the application to know on the given page how long it took after all the assets had been rendered, after the user had received everything they needed to actually make that tweet. And that kind of gave them kind of the overall view of user-centric performance. And so they, I don't know if they called it, but it was referred to as the user timing API. So the second half is all of the DevTools specific. So the best way I know to do this is actually, I'm just going to dive in and we're going to look at all of this together. And we're going to use it, we're going to do this together with, we're going to do this together with a Google search demo. And I'm going to see if Canary is working for me today. It is not. So Canary broke sometime in the last 24 hours. So you can't see this, or you can see that you can't see this, I should say. So I'm going to have to go and open up an incognito tab just to make sure that we can totally isolate the browser performance here. So I'm going to lower this just a little bit. All right. Yeah, I'm not sure. They just pushed 104, and now there are issues. So let me do, the first thing I need to do is I need to open up the Chrome DevTools. If for those of you who are not available, it's available in the kebab menu there. So we have, let's see, we have the Performance tab, which we're going to talk about today, and then at the bottom, if you have the secondary part of the DevTools, you have the Performance Monitor tab. So again, this is what we talked about earlier. Remember, we talked about the CPU utilization, and we talked about kind of the, so we talked about CPU utilization, and what you also get here are the kind of the JavaScript heap size, DOM nodes and event listeners, and documents. The combination of all four of these make up the sort of things that you care about when it comes to memory leaks. If these get larger over time without being reclaimed in a garbage collection cycle, then eventually you'll exhaust all available memory. Your CPU will peg to 100, and you'll get that aw snap that we saw earlier. So what I'm going to do now is I'm going to start a recording using the Performance tab. So here we go. I'm going to go to google.com, and I'm going to select this and type in Playwright. And hit enter. And we've got the results. We've got the results that we needed. And what was generated when I was doing that recording is this artifact. And this artifact, I'm going to go ahead and close this. This artifact is the performance timeline. And this is where you get access to, again, your heap, documents, nodes, listeners, and in this case, GPU memory. That's kind of your memory that you care about. You have your network information and the resource timings associated with each individual network request. You have your timeline view of everything that had occurred, so you can see when all of the assets were available. You can see when it became actionable, and you can see when I started to interact with it. When I went beyond the single page boundary and onto the second, you can see, and got the initial set of search results. But the main thing that I want you all to take away from this is that it's a lot. It's a lot. There's a lot going on. It's very dense. There's a lot to kind of suss out here, but just about anything that you would want to know in terms of web performance or client-side performance, you can discern from this view, this timeline view. And all of this is made available as an artifact, right? As a JSON file to import and export, so you can look at different snapshots over time. And I'm going to call out two more things here. You can see where the main thread, you can see this, harness the evolutionary part of your brain that says red is bad, right? Red blood bad. This is bad, that the long task on the main thread took longer than 50 milliseconds, and with enough contextual understanding of the web application and enough time, I guess we could all figure out what exactly is wrong in making this call here, and maybe look at ways to optimize it. I doubt it with Google search, but in any case, this is your long task, and this is being called out explicitly. And then the last thing I wanted to show, and I hope I can do this quickly, are the user timing. I think I lost. Oh, here it is. The frames, which relates to the FPS, and then the timings tab. So this is interesting. So the timings tab gives you a view of all the individual points in time that are associated with given events on the page, but specifically, interestingly enough, these individual slivers are actually contextual performance marks given to us by the Chrome dev team, or the Google search dev team. So the google.com search team put these marks in place to keep track of things that are interesting to them when it comes to performance. And unfortunately, they're obfuscated, so we can't see exactly what they are. But I could imagine they would be related to when I first interacted with a given page and what was associated with that first interaction, or the drop down of the list box. So I'm going to go ahead and just leave this in the background. And again, this is the performance tab. There's a lot going on, but it kind of completes the kind of the APIs that we need to understand kind of client-side performance. Anything that's not available in the official spec is exposed or made available in the DevTools itself. So we have the network. We have, in this case, these are timings related to this one in particular is the first paint. We have the user timing, or the performance marks here, and then we have our long tasks, all made apparent through this, this noise of a very, very noisy image. But the question then becomes, how do we get these from Chrome, and how do we get them programmatically and automatically? And the way to do that, one of the best ways to do that, I should say, is with a tool called Playwright. So Playwright itself is more traditionally known as a functional test automation tool. It's based off of Puppeteer. And Puppeteer is how the Chrome dev team tests Chrome, created for themselves so that they could test Chrome, test the internals, make sure that everything worked. And what ended up happening as I understand it, some of the developers were poached from Google to Microsoft to effectively make Playwright. And Playwright is very similar to Puppeteer, and some of the APIs are interchangeable, and we'll see that as we go through this. But specifically, what it was intended to do was support Edge, and so that's Microsoft Edge. I think it makes sense for them to support Edge, Chrome, Firefox, Safari, and iOS-ish. So it's sort of a iOS device. And so Puppeteer can only work with Chrome. In addition, Puppeteer, initially at least, only worked with JavaScript. Playwright supports Java, C#, Python, Async IO, JavaScript, and TypeScript. So you can use any language that you're familiar with, or most of them. I think the main one that's missing is Go and Ruby to interact with the browser. But it provides a very, very tight coupling to the browser internals, much more than is traditionally available in Selenium, which isn't necessarily important for a lot of test engineers. They don't really care too much about the browser internals. They're more interested in the spectrum of coverage that they can cover by writing a single test with Selenium. A single test with Selenium can cover many more platforms. But in our case today, what we want to know is actually something that's more specific to the internals of what's going on with Chrome. So we're going to use Playwright instead of Selenium. And that's because we kind of get these inside-out performance measurements that we care about. So the easiest way to talk about Playwright is actually just to kind of get started with it. So to get going with Playwright, you simply have to do these two commands, npx install Playwright and npx playwright codegen. So I'm going to do npx playwright codegen, and just to show you how easy it is to write a test, I'm going to start this up. And on the left you can see the Chrome browser, and on the right you can see this inspector thing that's going to make sense in a second. So I'm going to go and repeat what we just did, google.com, and immediately you can see what's going on here. So on the right hand side you can see await page go to, and then the URL, and on the left hand side you can see interactive view of what Playwright has access to and what it would do to locate and interact with that element. In that case, I'm going to search for Playwright as if I'm doing this manually, which I am doing this manually, and it's going to record all of those things and then along the way, and then give me access to this code that I can then immediately take out of this recorded session and put into my code base. So I'm going to go ahead and do that now. I'm going to stop the running test, go to VS Code that I have here, and I'm going to go to my, again, this is the repo that's available online, and you can see this code block here is exactly what was copied out of that record and playback functionality available in Playwright. So what I'm going to do now is I'm just going to run that just to prove that it's the same. npm run test local basic is the name of the test. So it's going to run this test that I just recorded. This is standard test automation stuff, right? I think it's cool, but this isn't necessarily while we're here. But what we just saw is how easy it is to kind of get started with something like Playwright. And so I'm going to go back over to the presentation and then talk about kind of the hardcore parts of Playwright. So we're going into the capabilities of Playwright now that we kind of got our feet wet and got started. I showed how easy it is to get started, right? But let's demonstrate kind of how powerful it is. So the first thing I'm going to demonstrate is talking natively to the Chrome DevTools and then getting access to the Performance API. So let's go back into our code, and I'm going to open up this first test suite and put a dot only on it so that we only run this test. And you can see that we take that same test from before. It's right here. This is the same test from before, but all we're going to do differently is we're going to instantiate a connection to the running Chrome DevTools protocol session, and then we're going to send a command to that running session and just say enable performance metrics. And then when we're done, we're going to send get metrics to that running CDP session and then log them to screen. We're just going to log them to screen. So same test as before, but we're just going to see what information we get basically for free. So instead of running this, I'm going to run local capabilities. So we took that same test, launched it. We're talking natively to the running Chrome DevTools, and bam, look at this. So this is all of the information that we got out of that test that ran earlier that's now available inside the test code that we can do whatever we want with. So you can see some of the callouts here. We have, remember, memory leaks. So we have the number of event listeners on this page, number of nodes on the page, and what we really are interested in is the kind of the heap sized. So all of this information is available to the test. All of this information is available from a easily written test case that you may have written yourself or recorded for yourself. And these are things that you can kind of keep track of and assert on if you'd like to. So let's move on to the next capability that I want to talk about.
Before we go there, question from Josh.
Sure.
How different is this from Puppeteer? Because I've used page.evaluate to do this, and things get weird. This seems a lot easier.
Yes. So it's some of the APIs are identical, and the thing about, I'd say the main distinction between the two is Playwright is written more for QA folks to get started with testing. So going and clicking on these certain elements and interacting with things is far more likely to work because of some implicit actionability checks. So in order for me to click on this ARIA label, search on google.com, it needs to be in the DOM. It needs to be visible, have the state of visible, and it needs to have stopped animating for 5 milliseconds. So when we talk about kind of flakiness and we talk about the distinction between Puppeteer, Playwright, and Selenium, a lot of the great things that come out of Playwright is all of these actionability checks that are automatically built in to everything that you do. So this is far more likely to succeed on multiple attempts, and there's less weirdness that'll happen just in general. But what I don't want to bury my lead, but I'm going to talk about the performance evaluate in about 10 seconds. But it is still working with raw data structures from JavaScript, and it is wonky. I've run into some issues, but I myself just ask the development team about it, and they'll usually fill in the gaps of my knowledge where possible.
Yeah,
but yeah,
I'll let you go on with the rest of it.
Oh, sure.
We'll talk more about other questions later.
Sure. Yeah. Again, it's just about action. The main distinction is actionability. The actionability checks. Let me go back. So the next thing I wanted to show is this one here. So this is the next capability. I want to show you that we actually have access to that performance timeline trace, the raw data, and we can record it at any point in the test that we're interested in, or not at all. But back to your evaluate wonkiness. Because we have this tight coupling between the browser and the test framework, I can actually just inject my own marks into the browser arbitrarily at any point. So that's one thing you can do. You can evaluate basically anything inside the browser from your test, and then do whatever you need to from that point. So in my case, I'm going to take that same test. I'm going to start a trace. I'm going to inject my own marks that mean something maybe only to me, that don't modify the application code, including my own measures, but include them alongside all of the existing marks and measures that come from Google, and then include those on the performance timeline. So let me do that really quick. One worker. So running the same test, and again, this is going to get very boring. I apologize. It's not doing much. But in this case, it's not doing much differently under the hood. But what you see here are all of the marks, both from the Chrome dev team and from myself that I've kind of injected into the page, and then the measures between them. So the measure is literally just you come up with this measure, a variable, and then you pick two marks arbitrarily. So you could even measure the difference between a Google one and your own if you wanted to, for example. I don't, because they obfuscate it in a weird way, and I tried that once and the demo broke, and then I was a little sad. But what we can do here is we can take that file from the test run and go back to our session here and go and import it right here. So this is what we just ran, the test. So that test generated exactly that same trace from before, but the main difference here is this artifact also includes our own marks that we added from the test, right? So these marks are included in the timeline. So you can do anything you want at this point with these. So if you wanted to measure your own things in the application, you can. If you want to make your own marks or make your own measures, totally up to you. Totally, this is using the same thing. More to that point, this object, this artifact, is just a JSON blob, and so you can get pieces of information in and out of it as needed. It's great. And then the last thing I'm going to show is API interception and FPS measurement. So I'm going to go back into our test suite here, get rid of the dot only, collapse this test, and I'm going to go to route image placement. So I'm going to do two things. There is an open bug that you can only modify routes by disabling the service worker. So I have to, when the page loads, I have to delete the service worker. Not a problem. There's an open PR to fix that. I'm not sure when it's going to go in. Similar to before, I'm going to connect to the running CDP session, and I'm going to send a command to show the FPS counter over top of the running page. Next, I'm going to wait for the Google logo to come through and replace it with one on the file system for Bing. Their nemesis, I guess. I don't know. They're probably pals. I don't really know. But all of this is going to happen while the test is running. And the significance of this, and I'm going to take a screenshot at the end. The significance of this is now that you're in the browser, with performance tests, you can modify any sort of API request or anything that you would want to modify on the fly. So you can imagine, like, if you have some particular image or some particular API response coming back from your CDN in a weird way, you can just stub that out effectively and keep a better view of web performance for your specific team that you might be on. So maybe you have one part of a page that you are worried about, but this other team, they're a bunch of jerks and they never have accurate resources. You can just stub that out and continue on your way. You can also stub out individual parts of an HTTP API response, request and response, and anything in between. You don't just have to do static assets. So I'm going to go back to the tests, open up this, and go and show that while this test ran at the very end, it was using this amount of GPU memory, and it had 27 frames a second. So an artifact to kind of keep track of. So on my team, we have certain displays that certain people, certain scientists are going to use. So we kind of keep track and make sure it stays above a certain level, a certain number of frames per second. during the course of the test. Okay, so let me go back. So those are really 6 capabilities smashed together, just for the speed at which I can execute things. I'm going to show 2 more. Like I said, I'm on a journey here, and certainly not selling you all on anything. I have 2 more capabilities that are proven. Sorry, these work, but I'm not going to stand behind these. Yet. So the second one is the Performance Observer object is a browser-based API that allows you instantiate this Performance Observer object, and then you say, hey, be mindful of these events and measure and monitor these events over time. And the one that we care about is the long tasks API. So I'm going to go into the code here, and going to the add observer. So what you would do with this is an example of the test that you would write. You would add init script the location of this this function here, and then when the test begins and the page is initially loaded, you instantiate the performance observer object, and then you push things arbitrarily to it. In this case, I'm pushing long task entries, pushing it to it, and then at the end I read it off. Furthermore, I'm taking that one step further, and I'm triggering more of these long tasks. Remember, long task is every time the main thread is pegged for 50 milliseconds, I'm actually throttling the CPU to artificially trigger more of those tasks so that I can be more mindful of where they might occur with a less powerful machine, for example. And again, this probably works. Like if you were to run this in a test, it has an output, but I don't know exactly yet whether or not this is really getting an accurate view of those long tasks, and it's something that my team is going to investigate further soon. Har File. So the other thing you can do is, in the same way that you can record the performance timeline, you can actually record the Har File, which is the complete suite of network requests as they're being sent across. So you can then have this artifact that perfectly captures the API request and response that you're generating from your user in your performance test, your front-end test. And then you have this artifact that you can then do something like run it with K6 or JMeter to simulate many users. So, so what that looks like, that was generated in that test that we just ran. So I'm going to open up K6, and I'm going to just, let's see, I should be able to go back to test builder, configure. I'm going to delete this test. I'm going to take this Har file that was generated and then create a new test, start building, and then import the Har file that was recorded while we were going to google.com right there. And then I'm going to run this as a virtual user. And this is going to convert to a script. And again, I think most load testing tools have this capability where you can take a Har file. But what I'm really trying to demonstrate here is that you can take your existing Playwright performance test, record the Har file along the way, and then convert that into a virtual user. So if you're going to run your performance tests, your client-side performance tests, and you want to simulate many users, what you can do is you can run your client-side test once, capture the Har file, convert that into a virtual user for JMeter, K6, whatever you're going to use, then simultaneously generate as many users as you want for that given user journey that you have, and simulate as many users as you want. Because the cost of running a real browser is quite expensive. Yeah, there you go. We just load tested google.com and they did great. Good job, Google. Anyways, so that's one technique. Again, I haven't done this yet, so I don't know all of all the problems that are going to occur. I have used Har files for JMeter in previous projects I've worked on. So yeah, worth calling out. So let's talk about some of the challenges associated in performance Playwright testing. The main one is test drift. So this comes from Dynatrace's synthetic monitoring tool. So this is a paid-for product saying that generally difficult because whenever a minor application element, such as a button change, the corresponding test must be too. So I call this test drift in the same way, there's configuration drift in IT where somebody will modify something and then it'll be out of sync. The configuration is drifted from the code. This is kind of test drift. And so the way around it is to use something like Playwright. And so this is something that's actively going on. Whoop. Oh goodness, this is something that's actively going on today. He may have even merged it in, but on my team, so I've open sourced all of the performance tests downstream, and they run on every commit. They don't assert on anything, right? And they don't record they don't push the data anywhere. They just make sure that when I run my downstream tests on internal to the NASA network and everything, that they more or less match the state of the application that is behind the closed source. So you can see here I run the visual test, functional test, and also the performance test on every commit. And you can see this person is dramatically improving our search capabilities. But with that, we need to also change some of the locators. So this ensures that my performance tests, my client-side performance tests, continue to work downstream, even as, for example, the class name, changes. So it's a technique. By leveraging Playwright, I'm actually able to share the same code base. So all of the developers are now totally capable of writing functional tests. And by extension, they could actually, if they wanted to, write performance tests. So it's a pretty great way. And if you take a look here, you can see where I'm adding my own marks. So the idea here is, with time, if this becomes an interesting performance measurement, actually get this baked into something about the search results. So that's something that I hope to do tomorrow. Actually, is get some of these performance marks built into the code, so I can rip out the page evaluates.
Quick question about Har File. How did you generate it?
You just so you add it to the Playwright config here. Where is it? Yeah. The record har comes with the browser context, and you just provide the path to the given test. So you could. So this is the Playwright test framework. That's defining that the local Chrome that all my performance tests are running on are using these properties. So the viewport height, the timeout values, headless or not, and at the same time you can send in that you want to record a har for every test that runs. So that's where that's set.
And another question was related to Cypress, how that compares, and also some conversation about this asynchronous, being able to run the synchronous calls and still get the results back. Something.
Yeah. So yeah, exactly. So Philip Harik, I think is his name, went to my talk in March, and he's a Cypress ambassador. And he provided a example of exactly how to do that with Cypress based off my talk. So I can, after I'm done with this, what I'll do is I'll include a link to his work on how he implemented marks using Cypress asynchronously in exactly the same way. Again, that's a browser API. That's nothing to do with Chrome or Chrome DevTools. That's just something that's built into all browsers. So something to be mindful of. And to speak more specifically to Cypress, I actually implemented our first end-to-end suite, functional and visual, in Cypress, and then had to rip it all out to put in Playwright because it's for the challenge that I'm trying to solve here, which is keeping the performance tests working alongside development as the development changes. It was going to be too much to kind of keep Cypress and Playwright. So I just ripped it all out and just used Playwright. But you totally could do some of the same things with Cypress, but not nearly to the same extent in terms of the performance observer thing, for example, I don't think you could do.
And a quick follow-up question on Har generation: will it generate many? Will it override the Har file if you run it multiple times? Yeah.
Yeah. So this was updated. Yeah.
But will it do it for each test, or will it generate multiple Har files per test?
Oh, I see. Yeah. So in that case, you would want to do something like I've done here with the fixture file, and then you would want to extend the base browser class, and you would want to do the base context class, and then start and stop the Har file from within a base fixture like this and rename it. So instead of naming it har, you would name it the name of the test based off of this browser context that you're extending. That's a good question. Again, that would be something that I think I'll eventually solve. I just haven't. We're just not there yet. We talked about challenges and solutions. So network, remember, so we talked about network being one of the leading problems associated with web performance. Well, the best thing to do is just get rid of it. So you can get rid of it by running. So the traditional problem with running some of these load testing tools, especially some of the SaaS ones, is that you need to run them kind of outside of your internal network. So you basically introduce the entire internet in between your synthetic user monitor and the web application. So you have to do a lot to remove the intranet variable. So when you're doing something like Playwright and doing it DIY, you can just run it inside your same network. In some cases, you can run it on the same host as either your backend, front end, any part of your internal network that you would want to most minimize in terms of network delay. Then, once you've removed it, then you can control it. So in the same way that you can use the Chrome DevTools to inject network latency profiles, you can just do the same thing in your test case, right? So in your test case, you can just add 500 milliseconds of latency. So you can then create individual profiles. Once you get latency to 0, then you can then totally control it and do whatever you need to either simulate your users differently or simulate network conditions that would have impacts on the front end. And then, yeah, kind of just to talk about the network control that we looked at earlier, this is the code of routing and fulfilling the Bing image into the search. But the more specific example would be, so on my team, one of the database calls has everything to do with the database of the environment that you're in. So like the QA environment, production, stable, all of those things have different size databases and different responses. So what we've done is just mocked the response payload. And made that the same so that the rest of the application and associated calls are more controlled. And so you can get a more more accurate view of the other parts of the application that you care about. What we haven't done yet, which would be really great, is to take that API response and make it much larger to start doing some of the proactive performance engineering tasks, like see how the front end would work when you have thousands of a given folder type, right? All of these things. And you can also inject your own latency to these routing requests if necessary. The next thing to talk about is transferability. So a lot of the times people will have like named performance machines that the metrics are only tied to, the measurements are only tied to. And your machine's not going to be the same as mine. This machine is different from the one right next to it. So the best way to get around this is to use a tool called Browserless, which is effectively Chrome as a service. And it does way more than we have time to talk about today. It deserves its own series of talks. But it basically becomes the interface for performance testing because it's Chrome and all of the essentials in a container, which is very difficult for anyone that's managed a Selenium grid. It's not trivial, but it exposes a generic CDP endpoint for your test to use that they connect to via a connect over CDP API. and gives you transferability because you can lock it down with C group control. So you have this browser that is the same everywhere, or presumably the same everywhere, 2 CPUs, 4 gigabytes of memory, something that is transferable and that you can measure. So what I have here is instead of running it remotely, I have it running locally. And so this is the web UI that it comes with. So I'm going to hit the play button, and this is a Playwright script or Puppeteer script, I'm not sure. But what you see here is the test on the left. On the right, you have a video of the test running, and then access to the Chrome DevTools associated with this browser that's being pumped out. So my 2-year-old just got home, so I'm going to deflect them to go down to the pool. Yeah, so this is that test running, and if you want to have direct access to it, you can get a video of it running in real time, or if you want to run your own tests, you can go browserless capabilities. So let's run that same test that we just ran a second ago, but instead of running it locally with a local Playwright install, I'm going to run that with this containerized Chrome instance. Let's see if it runs. It did. Oh crap! Okay, so this is that test running, and then this is just that that same test is running in a Chrome in a container. And so what you could do is you could keep a version of Chrome running on your network, basically attached to any part of your internal IT network that you care about, and then connect remotely to it with the remote CDP. So it basically looks like this. So you can basically move browserless as close as you need to any individual part of your internal IT infrastructure, and then connect to it via the exposed connect over CDP interface. And so effectively you start with 0 latency, and then you can kind of inject your own to create any of these network profiles. And again, this is a transferable thing. And then the next thing to talk about with transferability is creating a machine baseline for these results. So even with controlling this with Chrome as a service, there's still going to be times where you need to create another layer of transferability. So with this one, what you can see, I've taken a test, and what I've done is I've basically injected HTML, and then I check for that HTML that I've injected, and that time between the two, the console time, is how long it takes this particular machine to run and generate results. So before I run any of the tests, I just get a zeroed baseline, basically. And there's still a lot of variance in this. And what this gives me is this is kind of like the thing that becomes the baseline of all measurements. If I'm testing and measuring nothing, then I know how that compares to the rest of the web application that actually has real JavaScript. The last few things to call out: precision, accuracy, and variability. Leveraging browser time from the performance APIs is great. So instead of keeping the system time like you saw here, it's great to use those performance marks to keep everything in the browser, to keep a browser-based view of all the time metrics that you have, because it's very precise. The browser time is in the order of microseconds. And the next thing to call is, Playwright itself is going to change, Chrome is going to change. Here is a Chrome bug that was just fixed that impacted our functional test, just fixed, I guess, last week, where basically they broke one of the sizing APIs, and it broke our performance test and our functional test because Chrome changed, right? That's all I'm trying to illustrate. But you're still going to have other sources of variation. You have run over run variation. And how do we know if a 10% decrease in a certain metric is an application change or just in the noise? Even after we've controlled as many variables as we can. And that's to run your tests a lot, and it becomes a data problem. So the way that we've solved this is with Influx Db. They provide it's a time series database very similar to Prometheus for those that have used it, but it provides a native JavaScript client that you can just add to your test. And what's great about Influx versus the rest is you can modify the timestamp as you send it, versus Prometheus, which its view of the world, its view of time, its view of measurement is the time at which it received a data point. So when we're worried about accuracy, this matters. And so this is what this looks like, right? You basically have your test measurement that you care about, some things about it, and then the date.now, for example, if that's what you're going to send. So it keeps a very accurate view of measurement. Yeah, so that's in summary. We talked about client-side performance. We talked about what to measure. We talked about Playwright, and we automated a Google search performance test to some degree. And then we talked about some of the problems and associated solutions. So with that being said, I'm going to spend just a minute talking about kind of what's next. So this is a really exciting space, and it's by coming to meetup groups like this that I'm able to keep aware of what all is going on in this world. One of the next tools coming up is XK6 browser. So you saw K6.io, which is a traditional API load testing tool. Well, that team is creating their own kind of container by way of a Go-based performance measuring tool that's using Playwright APIs effectively to do what I'm doing today. It's in beta, and it supports the Connect over CDP if you're interested. But what it solves is it basically allows you to generate as many measurements as you need, and then tap into that huge K6 ecosystem to correlate any sort of events that you have in terms of your system monitoring or anything that's going on living in your system. You can automatically just pump and get in by you tapping into that ecosystem. And then for me, I need to push everything into a performance observer, and again, I don't know if that's actually going to work. And then someone asked about Puppeteer and Playwright. There are two APIs missing from Playwright with regard to performance, and one of them is a great way to automate memory leak detection. So I'm going to have to do this by hand. And then the last thing is there seems to be some performance timeline library parsers out there, but they're from like 2017, and they don't seem to work with any of the off-the-shelf things that I'm doing. So I'm hoping that comes into existence, or I find the right performance timeline parsing library, because then what that'll effectively allow me to do is anything that I generate during the test, I can actually just request out of that performance profile timeline view, and then have total access to that in kind of the test case. And then the last thing, so the front-end tests are all in Playwright, and we've started an initiative to open source everything. And so this is a great opportunity to contribute directly to NASA. So a traditional CLA applies to our tests that applies to the regular web development. So it's as easy as it looks to kind of get started with Playwright. I've onboarded 4 open testers, and all you basically do is you go to this GitHub discussion, put your name in, and then we'll get you started. It's a great way to contribute. It's awesome, and a lot of people have found it to be fun, which is I think Playwright is fun. So I'll end it here. Thanks, everybody.
Awesome. Thank you, John. Looks like we have some echo when I speak. When I speak, I need to mute you or something like that. Okay, it works when it's perfect. So amazing. I mean, this is mind blowing. I just want to highlight that when you came over to Meet for Speed, I was like, my mind was blown with how the problem is so different from what we usually do, right? A lot of measurement, we say, well, let's do real user measurement in real time. And then we discussed how, well, for you, real time is very precious, and you have to do it way before you start the mission, right? So you cannot test any of this as mission runs. And it was like very different world. And obviously these kind of tools are like the only way to accomplish this. And this is very deep and, so If anyone has any questions, please post them in the chat. I do have a question myself. So I noticed that when you send those client requests through Chrome Developer Protocol, I guess, CDP, right? You use some commands. How do you figure out what they are?
I use them actually with the technique that you showed, which is the DevTools and DevTools approach, in one of the meetup groups. That's and some of them were just kind of found off of the web. A lot of what I've done came from a lot of the work from synthetic user monitoring teams, and so that's where I've got some of them. I am looking for a few more with regard to getting more precise frame measurement is really what I'm looking for. Looking at inspecting screenshot images is kind of doesn't scale. So I would be interested if anyone out there has a better frame per second measurement that's available in the DevTools, for example.
Okay, let's see if we have any other questions. Tanner is asking, to simulate mobile devices, would you just use Playwright throttling options, or is there something like browserless for mobile devices, or say integrated with web page test?
To simulate mobile devices, to simulate a device, you could. So I can show you what So one of the requirements for the mission is iPad. We've disabled this, but what you can do is, let's go to CI. You can generate, you can use an iPad, which is basically using the open source WebKit browser, and then sending more than just, it does a little bit more than just send a proper list of user agent stuff. But it wouldn't, for example, it would give you the rendering that you need and the view that you need for iPad, but it wouldn't do anything more than what you see here. So this is effectively the view of the world when it comes to using the Playwright devices for mobile.
Ozzy is asking, oops, sorry. Ozzy is asking about resizing and setting viewport size, waiting for timeout. I'm not sure I understand the full question though, but
so the way that I manage browser sizes is to use profiles in the Playwright test framework itself. So the Playwright test framework, like right here, allows you to set certain mission sizes. So like this one is unique. So we do know during the mission what resolution people will be using for the monitors. So like they were bought and paid for on the government's, I guess it's your tax dollars at work. So we know what the viewport will be. So we have the special profile for those monitors here. So I that's how I do it. And then when I run the functional tests, I run them all at that resolution. But interestingly, I don't do that for the performance measurements. So for the performance measurements, I actually go into the lab and I take real measurements with a real device for kind of the final thing with a real monitor, just so I can get everything down, including the GPU itself, which is hard to do in containers.
Yeah, we hit some problems with GPU testing in our work. We're very flabbergasted by that. It's a problem. Another question from Josh. So do you not trust using Perf Observer API in here? I know you said work in progress. What is your main concern?
Yeah, exactly. Yeah, so I don't want to undersell it. We haven't used it yet. But it's a way to. I don't know if the long tasks, for example, are being triggered because of the communication between the browser context and the Playwright context. So that I'm getting back an accurate list of long tasks, but I don't yet have the attribution associated with them, and I'm not sure yet if it is due to just the interaction between Playwright and the browser. But if I wanted to measure things other than long tasks, like individual resources and everything like that, I would totally trust that. But I'm more concerned with that. Can you test that against? Yeah, that we just have. I haven't done that yet. Exactly. Yeah. So I think I will. I think I'll get there. I think I could get there faster if you all contributed some open source end-to-end tests. Yeah. Just it's just dividing up my time between functional and performance.